Hey, what's up guys? Jay here, and I'm kind of filming myself right now because Phil's working on a different video. But now that my build is done, it gives me an opportunity to test something I've kind of been wanting to test ever since we did the Alienware video where they talked about the fact that they're using all intakes and going nothing but positive pressure, including the top fans blowing down through the top of the case. I'm gonna take this opportunity right now with my 5090 Astral, which is water cooled in here, to kind of do some fan arrangements to see whether or not that would hold true in a chassis like this. Now, because the back chassis of this chassis is all mesh, I don't know how well that would actually work. So today we're gonna try a few different configs. I'm gonna chart temperature over time, and then we're gonna see which way is gonna be the best way to run these fans, and I guess be the most temperature efficient that we possibly can be. Enhance your professional monitor setup with the ViewSonic VP27885K, featuring 100% sRGB, 99% DCI P3 colors, and HDR400 for deep contrast that align perfectly with Mac's industry-leading color performance. The VP27885K supports laptops, PCs, Macs, and more with Thunderbolt 4, USB-C, HDMI DisplayPort, and USB inputs. If you're looking to increase your screen real estate for projects, click the link in the description for more. So if you haven't actually seen the build video, here are the specs real quick. It's a Gigabyte Aorus Master X870E motherboard. It's an AMD 9950X3D. Settings-wise, right now I have it set to PBO 90 level 3, so that means 90 degrees is the max temp, even though I went in and went ahead and made it 95 degrees, even though it'll never hit that. I'll give you some temps in a second here when it comes to CPU. I've already sort of tested that. Level 3 being how far it'll push the PBO. I was actually trying level 5 and it wasn't stable, so I don't know what frequencies it was trying to run, but that is just a very quick PBO enabled and leave it kind of a thing. I haven't done any sort of fine tuning on the CPU, but I can tell you the CPU is running 5.3 gigahertz all core on all 16 cores, both the cache die and the frequency die. Anyway, moving on, it's got 32 gigabytes of Team Group 8000 megahertz CL38 in there. I'm probably gonna switch it out to 48 gigs of the same RAM, but instead of 32, I'll have 48 total for two 24 gigabyte sticks. We'll see if that's on the QVL, so we'll see if that'll work, but I kind of want to play around with some of the RAM stuff for this. The GPU is the 5090 Astral. It is running the Delta Mate water block, which I did a video about with the Thermal Grizzly water block. This is actually one of their, like, I call it a deep prototype. It is not the final product, but it is also not the released product. So it's kind of unique in the sense that they don't have very many out right now, and this is not the final product. So it's just kind of neat to be like, hey, this is a one-off. Seems to be doing a pretty good job so far though, but we'll talk about the temps and stuff. Today, I'm gonna use the GPU to test the loop because my CPU, while running Cinebench, never goes above 71C. Yeah, in Cinebench, which is a very hard test to run, at least what it definitely likes to push the CPU temperatures as far as possible with that type of test. But 71 degrees is as high as that CPU goes with the dual 360s in here. It has a 1200 watt Be Quiet straight power GPU power supply in there. And then in terms of storage, it's got a T705 2 terabyte Gen 5 drive, and it's got a 2 terabyte P310 drive, which is a Gen 4 drive for my games and stuff like that. Cooling, it's got two EK water blocks, 30 mil thick by 360 mil radiators. I already talked about all the rationale why I'm reusing the EK parts that I already have, because I'm honoring the employees there that made great stuff. Unfortunately, they got screwed by bad management. So I can honor the employees without honoring the ownership of the brand, if that makes sense. That's kind of it right there. So the GPU settings are stock. I'm not doing any sort of additional power management or pushing up the core clocks or anything. It runs about 2755 megahertz on average with the water cooling in there. And yeah, so what I'm gonna do today is I'm gonna set up, well, I've already set up Hardware Info 64. It's one of those utilities I said everyone should have. It's free. It allows you to have full visibility of every single sensor in your system. And fortunately, the Astral gives us a lot of stuff actually we can keep our eyes on, which is great, because when I put the sensor panel in here, I can even see per pin amperage. Yes, the GPU Tweak software, or whatever they call it with ASUS, I believe it's GPU Tweak, can monitor the amps per pin on the 12 volt high power, but because it's a visible sensor to anything monitoring sensors, I can set up my sensor panel at AIDA64, and I can actually have the amps reading out per pin on the screen. So I don't need to be running the GPU software to see what those are. I can actually go ahead and have my sensor panel show that, and I can have it change colors and do alerts and things if they go above the spec that we're expecting them to see. So that would be a nice little security built in or a little bit of insurance built in to be able to keep an eye on that before any sort of physical damage could potentially happen with the graphics card. I am running a third-party 90-degree cable on there, so that's one reason why I would definitely want to keep an eye on that. However, it does have a very strong fit. Anyway, I'm talking more about the system than I need to right now. But what I'm gonna do is I'm gonna run 3 configs when it comes to this test. The way that this is set up right now, and in fact, I can use my smoke. I love the smoke machine. Hopefully you guys can see it. If I show you, we have updraft. So we have these 3 fans on the bottom are bringing air in through the gaps all around the PC. The gaps are all 4 sides, so it's not like there's anything blocking it off. The air is coming up. These 3 are exhausting out the top. The rear fan is an intake because I wanna try and offset with cooler air, the warm air that's gonna be brought in. Well, that's going to be exhausted by the bottom rad. So as the air comes through, it's going to be warmed up because it's going to be cooling off the hot coolant. And then that warm air is going to make its way up. So I'm mixing colder air with the back fan by pushing that in. Now this is what that flow looks like right here. Yeah, I think you can kind of see it. So as you can see, it is definitely it's not the best camera angle, but you can see it is coming in and going straight out the top. The rear fan, as you can see, is for sure bringing it in, and it's going through the top rad, which is exactly what I wanted. So here we go again. There it is with all the straight up draft. But, so that's the config that we're at now. I'm gonna go ahead and run that. We'll go ahead and do about a 20-minute GPU test on here. Then what we're gonna do is we're gonna take the side panel off. Just gonna take the side panel off and see how it compares to having this not be as affected by the bottom rad. Then what I'm gonna do, and that's just out of pure curiosity, I don't run an open side panel. A lot of people do that if their side panel, or their case they feel like maybe isn't having the most optimal airflow. But because of the way that the Corsair Link fans are, I can actually flip the top 3 fans and I can access every one of these screws. I made sure the way I did my tubing, none of those screws are blocked. I can actually get all of those screws out. Right? Yes, I can actually get all of those screws out, which will allow me to go ahead and flip the fans over and turn those into an intake. Now, the second I turn those into an intake, I need to either turn this into an exhaust or remove it entirely. Now, if I'm gonna try and mimic what Alienware did, they don't have an exhaust fan. Now, one of the things Alienware said in their documentation was that by having an exhaust fan in the rear with all positive, the fan couldn't actually keep up with the amount of positive pressure that those fans were pushing, so they opted to remove it entirely and let it just, all the air be pushed out. That's not gonna be the case with these fans, I don't think, because they had what, I think 180 millimeter fans or something in the front, 2 giant fans, and then 3 intakes on the top, and then some intakes on the bottom. So they had a lot of air pressure and a lot of CFM that this does not have. So I'm gonna try it with that set to an exhaust, and I think we'll be okay. But there's so much ventilation in this chassis. Don't forget the whole backside is also a mesh panel, as I already said. I don't think we would have a problem with being able to push that air out. So I'm gonna go ahead and cut right now. I'm gonna go ahead and start running our temperature tests. I'm gonna graph that out and then we'll come back and see the results. I'll be honest, I don't have a prediction here. I really don't. I'd like to think this might be the warmer config just because we're introducing warm air into the system with the bottom rad. But in terms of cooling efficiency, I actually, now that I think about it, think by flipping the top fans and having that have cool air coming in through the top as well, could only make the radiators more efficient because there's cooler air being accessed to that rad. So, and not only that, I know people were like, but heat rises. The fans overcome the very weak force of convection very easily. So by flipping those over and having them be intakes doesn't change anything. If anything, the only thing I would probably have to do is put my fan filter back in the top. I did take it out. I live near the desert. It gets very dirty and dusty. I have dogs, so I would want to keep as much of that out as I possibly could. So I will mention that in this config, the exhaust, there is no filter on the top. There's no reason to filter the exhaust air coming, or the air coming out. When I flip the fans, I will put the filter back in, so we're dealing with all filtered intakes. All right, so I'm shutting down the system here. I'm gonna go ahead and switch the fans out and kind of take you guys along for the ride on that. I've already done the first 2 tests. I just kind of want to give a little bit of a showcase here about what I mean about being able to switch my fans around. Now, Corsair and the Corsair Link stuff, it's gone through some growing pains, that is for sure. And this is not sponsored by Corsair or anything like that. And the pull tab already pulled off this end plug here. So trying to get that out, it's a complete pain in the butt. And the problem with a lot of the RGB stuff is there's just no uniform standard or unified standard. So there's a lot of people that give hate to this stuff when it comes to RGB and whatnot, and it's all very warranted. Anyway, I think personally Corsair has... Okay, this is just another example of me trying to use something that I have heard a lot of feedback about that we haven't really done much with or touched a lot since it first came out. So I want to give it a shot. But you can see I've unplugged literally nothing from the system here. And I'm just going to go around, take the perimeter screws out. The 3 fans will come out together because they are interlinked. And then I have to do the same thing here and flip the exhaust fan. So, like I said, I can just bring them out. And the cool thing is because there are plugs on both sides, and they'll end up in the exact same side, I don't have to worry about whether or not this cable is now going to line up. Because as you can see, I flip it over. This is intake this way now. You can see the plugs right there. If I flipped it over this way to exhaust like it was, the plug is in the same spot. And it doesn't matter which side it goes in. So I think that's kind of, I personally think that's neat. All right, so finishing up here, I've probably been at this for about 5 minutes. You know, this is what I gotta say, love them or hate them. This is where the Corsair, God, I know I sound like I'm fanboying. I haven't used a Corsair product in any of my builds in a long time, but I mean, look, I flipped it around, that one plug cable right there just plugged in, and now everything's back in. RGB, fan control, fan sensors. Each one of these fans have a sensor, a temperature sensor in it, which is awesome. But if I was to do this with traditional fans, I'd have to go around to the back, unzip tie, unwire them from whatever hub they're plugged in to pull the fans out, run the new fans in, run the wires, plug all that in. I love the idea that it's this one plug cable. And it had its growing pains at the start. When they first showed me that, I loved the idea, but at the same time, it's one of those things where it's like, I know that it's not gonna be perfect and it's gonna take some time. So that's one of the reasons why I waited so long to use them in any builds of my own. See, watch, here we go. Just unplug that. And I'm hoping, really hoping, that I'm not gonna regret using these fans. And not only that, because they look more at home in the Be Quiet case with these lines on the side of the fan versus the lines on the front of the case and the side of the case, they look more at home than Be Quiet's own fans do. See, I can flip this over now, that way. It just sucks now that these are gonna have all the X's showing, but this is not. But whatever, I don't care. I can go ahead and plug this back in, boom, screw this into the case, and then we're good to go. So, I mean, it's kind of hard to hate the easy access of plugging it in and moving it around and daisy chaining and such, but I can understand everyone's hatred for the whole IQ suite and RGB and all that stuff. That's all very valid and warranted type of critique and hate. All right, a few hours later now worth of testing. I got some results here. Interesting results. I said earlier that I didn't have much of a theory, and then I changed that and said, well, I think the intake top and intake bottom are gonna have the best results. I don't know if the data necessarily supports that. Okay, so the 3 configs, like I said, we tested, which were updraft, and what I'm denoting as updraft is intake on the bottom, exhaust on the top, and intake on the back. So we're forcing all the air up through the radiators. Now, my concern there was that we were going to be putting pretty warm air into the system, only warming up the top loop, or the top radiator, which actually kind of is kind of represented here in the light blue line. So if you look at the teal colored line, you can see it's not quite done climbing yet towards the end of the chart. So that shows me 20 minutes wasn't quite long enough to reach equilibrium, but we can see the trend, and we can still sort of denote which is the better configuration, at least with this setup, with these parts, by looking at the trend lines. So you'll notice the charts are kind of really jagged. That's because I didn't use any sort of an average algorithm. This is just the raw data. But as you can see, the updraft started at the lowest temperature and then was actually the warmest temperature by the end of it, reaching about 57 C on the core. Now keep in mind, I know that sounds pretty warm, and it actually is pretty warm, but it's a 600 watt GPU. And it was running on average about 580 watts in Steel Nomad. Now, Steel Nomad is a very difficult test to run. It is the hardest rasterization test 3D Mark has ever made. So even though it's not touching the RT cores and stuff, it allows those CUDA cores to go full balls to the wall in terms of frequency. In fact, the frequencies actually go higher in rasterization than with something with RT, because the RT cores technically have a lower clock speed, and it can affect and actually slow down the CUDA cores waiting for the real-time ray tracing to take place, giving yourself sometimes an overall lower temperature when using RT versus just rasterization, if the test is not difficult enough with the RT test. Now, Steel Nomad is a very difficult test to run, which is why I wanted to use this for temperature testing. Now, if you look at the purple line, or the pink line here, that's the updraft with the side panel open. Now I learned something interesting. Before I saw the results, I thought that they were going to actually be pretty bad. And the reason why I say that is if you look at this video right here, you can see with the smoke machine, the bottom radiator, because it is fans blow air in a conical pattern, not straight up and down, but it's a cone. Everything comes off as a centrifugal force, right? Air has mass and volume to it as well. So as air is spinning, it also wants to move outward, which is exactly what the fans are doing. They're scooping the air, and that scooping spinning action of the blades also creates a vortex and a centrifugal force to the fan, or to the air that the fan is moving. So that means the bottom radiator is creating this air that's pushing out of the chassis once the glass is no longer there. So as I'm moving the fog machine around, you could see the top radiator looked like it was kind of getting starved for air, where the bottom fans were moving so much air and pushing it outside that the air that's outside the chassis wasn't getting sucked in by the top rad. So I expected it to be a pretty bad result. It was actually the best result on here. So clearly what looks like is happening sometimes physically with the smoke isn't the reality of what's happening, because that top rad was obviously getting air, and it was getting fresher air that's less heated by the bottom radiator, which gave us the better overall result, landing at about 51.5 to 52 C. So we're already 5 C down. When we take a look at the just taking the side panel off, we're like 5 C down. Now I know that this line is very difficult to actually see those numbers because I wanted you to see the full scale of the chart. 0 to 80 C. Actually 80 C isn't even the max. I think like 83 to 85 C is where the max is actually for the 5090. So I wanted you to just kind of see in a full scale of what that looks like. I'll zoom that in a second. Now, if we take a look at the top and bottom intake with rear exhaust, that means we have air being pulled in through the top and air being pulled in through the bottom, and then it has to make this sharp 90-degree turn out the back of the chassis. Now, all the fans were fixed at 65%, including the rear fan. And I think this one ended up having a fairly mediocre result, because what I needed to probably do, and I should have tested this as well, but I just ran out of time today, was actually leave the rad fans at 65%, but then speed up the rear exhaust fan to help get that air out faster by moving that up to maybe 75 or 80%. Now I chose 65% fan speed for this particular test because that's about where the acoustics are that I can tolerate the noise. Above that, because these are 2400 RPM fans, they can get pretty loud and pretty noisy. So obviously, this is not the full cooling capability of this loop. It's what the loop was capable of doing cooling-wise at 65% fan speed. So I think if I'd run that test again with the rear fan turned up more to just cycle that hot air out faster, it could have been a better result. But that one landed right around 53 C. So you can see we went 57 C, it was about 57.5 C as the max temperature on the normal configuration with the updraft. With the side panel open with updraft, we dropped it down to about 55 C, and then 53 C was what we saw with the all intake with the rear exhaust. So you can see we were dropping only about 2 C every time we did something. Now if we zoom that chart in, you can see it looks like everything's still climbing, and it actually kind of is, because I think realistically I needed 30 minutes to probably get full equilibrium. You can see now what I mean by the fact that the open side panel actually started with the worst temperature, which is kind of funny because I did fully cool the system down between runs, let all of the heat soak dissipate, made sure nothing was pre-warmed up to throw a wrench into our results. Started the warmest and then actually was the coolest by the end of the test. You can see right around the 10-minute mark is where all these numbers kind of cross. But you can see what I mean by our yellow line being right in the middle there with the all intakes with rear exhaust, landing at right around that 55 C on average. Now it's jumping around, like I said, there's a lot of raw data here. So if you actually drew that median line, it actually is right around 55 C at the 20-minute mark. Again, all three of these temperatures were still kind of climbing very, very slowly, but it is what it is. Also too, the coolant temp hit about 41 C with the hottest test and about 38 C on the coolest test. So 4 C difference in terms of fluid temp between those, and that makes a lot of sense because the fluid temp and the component temperature would rise linearly as well, just like as ambient temperature rises, so does the coolant temperature. So it's all related in that aspect. Now, those are just temperatures. The temperatures don't mean anything unless they're affecting our frequencies. Now, if we take a look at our clock frequencies, you can see at the full scale of starting at 0 megahertz going up to 3000 megahertz, it's a wash, right? So we had about 4C difference between our 53 hottest, our coldest, and our 57.5C hottest. You can see it really didn't affect our temperature, our frequencies that much, at least when you look at the full scale of things. If you zoom in on that, this is where you can actually see the yellow line being, again, the full intakes. It actually has lower valleys. Now, the peaks are not as high as the teal line, as you can see, which is technically the updraft, right? Those had the highest peaks, which is the highest bin frequency. But the yellow, which is our intakes with rear exhaust, have the lowest valleys, which means on average, it's going to be a couple boost bins slower than the other cooling configurations. And that's very obvious here as you zoom in on the chart. Now, I have a theory as to why that might be. I really got to thinking about it. We have the hot air from the radiator on the bottom and the hot air from the radiator on the top smashing into the GPU. Now, the GPU in the Astral block, or the Deltamate block from Thermal Grizzly, the backplate has thermal pads touching the back of the core and areas on the back of the PCB that are guaranteed to generate heat. The back sides of the memory, back sides of the VRMs, backside of the 12-volt high power. A lot of heat is making its way to that backplate. In fact, that backplate is dissipating so much heat and doing such a good job at it. Remember, heat moves in 360 degrees. It moves out in a sphere. It doesn't just go in one direction. So that backplate, when I hooked my thermal camera, or turned my thermal camera on and pointed it at that backplate, when I was seeing 51, 52C on the core in hardware info, I was seeing about 50, 51C on the backplate right behind the core. So that tells me that backplate was definitely absorbing heat, which is going to require airflow to help dissipate. Now, having the rear intake on the updraft config tells me cool air was getting blown across that heatsink, which might have been why we were seeing, when I say heatsink, but it's a backplate, which might explain why we were getting slightly better temperatures, because it was having a bit of a heatsink effect. Now, one thing I wish Thermal Grizzly had done, which is what the Optimus blocks actually have, is the backplate is not only touching the key components, there's a thermal pad that touches the entire back of the PCB, and there's a heat sink milled into it. So you've got, it's not the most dense heat sink, but you have a heat sink effect milled into the back of that backplate, giving you a little bit more of a radiant heat effect on there, where you can get more of that heat out the backside of the PCB. So that tells me if I had an Astral block with like an Optimus block with that heat sink built into the backplate with that rear intake, could actually be giving us a benefit. Now, I think that'd be neat if Der Bauer offered a backplate that could do that. The cool thing is they could just offer a backplate replacement. It doesn't have to be a whole new block or anything. But I think that might be why we saw a negative effect of having the intake at the top, because that hot air and that coolant getting all the way up to 41C is warm. That coolant is warm. It means there's pretty warm air smashing into the back of the GPU, effectively potentially warming it up, versus the cool air that was coming in the back fan blowing right across it. Not only that, we're going to be blowing that warm air on all of the components on our system that are pretty important. For instance, the RAM in our by our CPU, our VRMs, our chokes, all of that stuff is going to be getting hit with pretty warm air. Now, warm air blowing over it is still better than no airflow at all, which is what you get sometimes with custom water cooling loops. So I have a feeling I'm probably going to end up flipping this system back to the updraft with rear intake. And then what I'll probably end up doing is, like I said, in terms of having a faster exhaust for the full intake configuration, I'll go back to an updraft and I'll just turn up the back fan to an acoustic level where I can tolerate it, which means cool air blowing across the back of the GPU, more cool air feeding the top GPU, which is what we're trying to counteract the warm air from the bottom GPU making its way up, and allow me to be able to get that cool effect across the CPU, the top of the CPU, the VRMs, the chokes, the RAM, and all of that. Because we could absolutely be warming up our RAM with that warm air that's coming down from the top. I also will probably change out the QX120 for a QX140, so I have even more CFM of air to be able to pull in. So I think there's some optimizations I can do to this loop that are going to be very easy to switch out, as I already showed you with the Corsair Link and the way it unplugs. It's actually a very convenient system to use. This is my first time doing a build with it, and as long as the IQ doesn't IQ on me, we should be okay. But I already had it one time forget its lighting, and I didn't change it. It just decided I'm rainbow today. I'm not going to pay attention to your mural that you have set up. So there is that. I've already experienced that once, and that's going to be extremely annoying. And I have no choice but to use it because there's no RGB pass-through to connect to the motherboard or OpenRGB or anything. You have to use iCUE. There's no SDK or anything that allow it to work with OpenRGB as far as I can tell. But there is that. Anyway, I just wanted to kind of get some data here. It's fairly anecdotal, but it gives us something to go off of. And there is tangible differences between the configurations that I have set. So with that said, I'm gonna get out of here. I'm gonna see if I can get a QX140 fan for the rear. I'm gonna flip that back to an intake, and I'm gonna flip my top fans back around to an exhaust so that, oh, and one other thing I forgot to mention, which is a little late now, I did not put the fan filter back in the top for the intake because I didn't want that to be a variable I introduce when we're changing around airflow configurations. Now, in terms of putting that filter in the top, obviously it would do filtration, like I said, if it's an intake and you have dust coming down from your ceiling or wherever. Remember, dust does tend to float around the room and it could be pulled in. But if I put that filter in there, would I have known now whether or not the configuration was the problem, or is it the reduced airflow because of the fact that we have a filter in there now with a fixed RPM percentage on the fans? That could have been an introduced variable that would have given us a different result, and we wouldn't have known now was it a configuration change or the filter. So I did not put a filter in there to keep it exactly the same by just flipping around the way that the air is flowing. But anyway, with that said, like I'm gonna change the rear fan back to intake, I'm gonna change the top back to exhaust, and then I'm gonna do probably some more trickery with getting the fan configuration and speed set up how I want, and I think we'll be good to go. All right, there we go. Sound off in the comments below how you guys feel this configuration is. I wanted to say we've probably been cooling our cases wrong the entire time, but I think right now the traditional type of layout with intake and exhaust is making the most sense. As long as we can get enough cool air to the top rad. Anyway, thanks for watching, guys. As always, we'll see you in the next one.